In this video, we will try to solve a problem on how to find the growth rate from the given aggregate production function. The question is like this. Suppose the aggregate output is given by y is equal to a into k to the power alpha l to the power beta. Y is the output, a is the total factor productivity, k is the units of capital used, l is the number of laborers used. Alpha and beta are the output elasticities of with respect to capital and labor here. Okay, so where a is the productivity parameter and sum of the elasticities of output with respect to capital and labor is 1. Okay, if k and l each grow by 7% and productivity grows by 3% in a year, the growth in output is, so we have to find out the growth rate in the output. Okay, so we are being given a typical Cobb-Douglas production function like this. Y is equal to a k to the power alpha l to the power beta. Okay, and also we are being told that uh, that is sum of elasticities of output with respect to capital and labor is equal to 1. This alpha denotes the output elasticity of, let me write it here, output elasticity of what we call capital. Okay, this beta, the exponent here, this beta is our output elasticity of labor. Okay, and this a is our total factor productivity, that very parameter which measures the change in the output which is not explained by the capital or labor. Okay, so we also call it Solo's residual. Okay, so what the question tells us, we are being told that sum of output elasticities of k and l is equal to 1. That means alpha plus beta is equal to 1. This is being given to us. Also we are being told that this, what we call, capital increases by 7%, labor also increases by 7%, total factor productivity, this increases by 3% in a year, and we have to find out the change in output will increase by what percent. Okay, simple thing. So how do we solve this very question? First of all, we write this Cobb-Douglas production function and we take log on both sides. Okay, so if we take log of both sides, this will become log of y is equal to, then we have log of a, okay, plus this alpha will become coefficient alpha log k, plus then this beta will become coefficient, this is log b. This is simply from, sorry, log l. This is by the law of logarithm. Okay, so if we have log, let us say log x to the power, or we have simply x to the power n. If we want to take its log, it will become n log x. Okay, that very rule that I have applied here. Okay, simple thing. Also if we have uh, x into y, okay, if we take the log of this very thing, this will become log x plus log y. Okay, these are the basic logarithm rules. I hope you know these very rules very well. Okay, so first we take the log of this production function. After that we take the derivative of this very production function with respect to each parameter. That means the derivative of log y will be equal to 1 upon y del y, okay, is equal to, similarly the derivative of log a will be equal to 1 upon a del a plus derivative of this very alpha log k, alpha will remain same, derivative of log k will be equal to 1 upon k del k, okay, plus we have this beta as it is, and the derivative of log l will be this is equal to 1 upon L, 1 upon L, del L. Okay, so we can write it like this: del Y upon Y is equal to del A upon A plus alpha del K upon K plus beta del L upon L. Okay, now this del A upon A, it shows us percentage change in total factor productivity, and this del K upon K shows us percentage change in capital, and this del L upon L shows us percentage change in labor. Okay, del L is change upon L. How do we take the percentage? Simply we see what is the change variable, we divide it by the original variable. Okay, then we get the percentage change. I hope you know this. So this will denote the GDP growth rate. Okay, and this del A upon A, that is being given us change in total factor productivity is 3. So I can write it here to make the thing simpler. That means del Y upon Y is equal to, so this very thing is 3%. Okay, plus we have alpha, percentage change in capital is del K upon K, so this grows by 7%. Similarly, we have plus beta, uh, del L upon L, change in capital is also being given us as 7%. Okay, so we can write it like this: 3%. If we take 7% here common, so this will become 7%. We are left with alpha and beta, alpha plus beta, which comes out to be 3% plus 7%. Alpha plus beta, sum of output elasticity of capital and labor is equal to 1. So we can write here 1. So we are left with 3% plus 7% is equal to 10%. Okay, del Y upon Y shows us percentage change in GDP. That the question was all about. Okay, so the growth rate of output. So this del Y upon Y is actually the growth rate of output. That means our output will increase by 10%. Okay, so if you are wondering how do I calculated this very step and what is meant by the Cobb-Douglas production function, how do we derive the Cobb-Douglas production function, and how do we prove what is this output elasticity of labor and capital, I have explained this all stuff in earlier videos in details. You can check out those videos and you can understand what I mean by this. Okay, so this A is actually our total factor productivity, that very amount of change in GDP which is not explained by capital and labor. This alpha denotes our output elasticity of labor. It shows how much our output changes when there is change in capital by 1 unit. And similarly, this beta denotes the output elasticity of labor, and this beta denotes change in output, okay, when there is 1 unit change in L. Okay, and this total factor productivity, we also call it shallow residual here. Okay, I hope I make myself clear in this video. So here it will be 10%, output will grow by 10%. Hope you like this video. Thank you.